A machine shop is a room, building, or company where machining is done. In a machine shop, machinists use machine tools and cutting tools to make parts, usually of metal or plastic. A machine shop can be a small business or a portion of a factory, whether a tool room or a production area for manufacturing. The parts produced can be the end product of the factory, to be sold to customers in the machine industry, the car industry, the aircraft industry, or others. In other cases, companies in those fields have their own machine shops. The production can consist of cutting, shaping, drilling, finishing, and other processes. The machine tools typically include metal lathes, milling machines, machining centers, multitasking machines, drill presses, or grinding machines, many controlled with CNC. Other processes, such as heat treating, electroplating, or painting of the parts before or after machining, are often done in a separate facility. A machine shop can contain some raw materials and an inventory of finished parts. These items are often stored in a warehouse. A machine shop can be a capital-intensive business, because the purchase of equipment can require large investments. A machine shop can also be labor-intensive, especially if it is specialized in repairing machinery on a job production basis. But production machining is much more automated than it was before the development of CNC, PLC, microcomputers, and robotics. It no longer requires masses of workers, although the jobs that remain tend to require high talent and skill. Training and experience in a machine shop can both be scarce and valuable. History. Until the 19th century, the first machine shops started to appear in the 19th century when the Industrial Revolution was already long underway. Before the Industrial Revolution, parts and tools were produced in workshops in local villages and cities on small scale, often for a local market. The first machinery that made possible the Industrial Revolution were also developed in similar workshops. The production machines in the first factories were built on site, where every part was still individually made to fit. After some time, those factories started their own workshops, where parts of the existing machinery was repaired or modified. In those days, textiles were the dominant industry, and these industries started to further develop their own machine tools. 19th century further development. Early in the 19th century in England, Germany and Scotland of machine tools and cheaper methods for production of steel, such as the Bessemer steel, triggered the Second Industrial Revolution, which culminated in early factory electrification, mass production and the production line. The machine shop emerged, as Burghardt called, a place in which metal parts are cut to the size required and put together to form mechanical units or machines. The machines are made to be used directly or indirectly in the production of the necessities and luxuries of civilization. The rise of machine shops and the specific manufacturing and organizational problems triggered the early job shop management pioneers, whose theories became known with as scientific management. One of the earliest publications in this field was Horace Lucien Arnold, who in 1896 wrote a first series of articles about modern machine shop economics. Quote, "This work stretched out from production technology, production methods and factory layout to time studies, production planning, and machine shop management." A series of publications on these topics would follow. In 1899, Joshua Rose published the book Modern Machine Shop Practice, about the operation, construction, and principles of shop machinery, steam engines, and electrical machinery. 20th century. In 1903, the Cyclopedia of Modern Shop Practice was published with Howard Monroe Raymond as editor-in-chief. and in the same year Frederick Winslow Taylor published his Shop Management, a paper read before the American Society of Mechanical Engineers, New York. Taylor had started his workmanship as a machine shop laborer at Midvale Steel Works in 1878, and worked his way up to machine shop foreman, research director, and finally chief engineer of the works. As independent consulting engineer, one of his first major assignments was in 1898 at Bethlehem Steel was to solve an expensive machine shop capacity problem. In 1906, Oscar E. Perigo published the popular book Modern Machine Shop Construction, the Equipment and Management of Machines Shops. The first part of Modern Machine Shop, Perigo focused on the physical construction of the building, and presented a model machine shop. With this model machine shop, Perigo explored the way the space in factories could be organized. This was not uncommon in his days. Many industrial engineers, like Alexander Hamilton Church, J. Slater Lewis, Hugo Dima, etc., published plans for some new industrial complex. These works, among others, culminated in the scientific management movement, on which Taylor in 1911 wrote his famous The Principles of Scientific Management, a seminal text of modern organization and decision theory, with a significant part dedicated to the organization of machine shops, the introduction of new cutting materials as high-speed steel, and better organization of the production by implementing new scientific management methods such as planning boards, significantly improved machine shop productivity and efficiency of machine shops. In the course of the 20th century, these further increased with the further development of technology. In the early 20th century, the power from the machine tools was still supplied by a mechanical belt, which was powered by a central steam engine. In the course of the 20th century, electric motors took over the power supply of the machine tools. In the second part of the 20th century, automation started with numerical control automation and computer numerical control. Further integration of information technology into machine tools led to beginning of computer-integrated manufacturing. Production design and production became integrated into CAD/CAM, and production control became integrated in enterprise resource planning. 21st century, the introduction of industrial robots in the second part of the 20th century further increased factory automation. Typical applications of robots include welding, painting, assembly, pick-and-place, product inspection, and testing. As a result of this introduction, the machine shop also has been modernized to the extent that robotics and electronic controls have been introduced into the operation and control of machines. Machine shop topics. Machines. A machine is a tool containing one or more parts that uses energy to perform an intended action. Machines are usually powered by mechanical, chemical, thermal, or electrical means, and are often motorized. Historically, a power tool also required moving parts to classify as a machine. However, the advent of electronics has led to the development of power tools without moving parts that are considered machines. Machining is any of various processes in which a piece of raw material is cut into a desired final shape and size by controlled material removal process. The many processes that have this common theme, controlled material removal, are today collectively known as subtractive manufacturing, in distinction from processes of controlled material addition, which are known as additive manufacturing. Exactly what the controlled part of the definition implies can vary, but it almost always implies the use of machine tools. Machine tools. A machine tool is a machine for shaping and machining metal or other rigid materials, usually by cutting, boring, grinding, shearing, or other forms of deformation. Machine tools employ some sort of tool that does the cutting or shaping. All machine tools have some means of constraining the workpiece and provide a guided movement of the parts of the machine. Thus, the relative movement between the workpiece and the cutting tool is controlled or constrained by the machine to at least some extent, rather than being entirely offhand or freehand.